Hello everyone and welcome to this presentation. My name is Khalida Douibi. I'm a data scientist and PhD in biomedical informatics. I'm really so glad to give this talk about the non-invasive brain-computer interface for industrial applications. Let me just introduce myself before starting this presentation. I am um, I'm a data scientist and PhD in biomedical informatics, and I am a part of Mind and Act project on Capgemini Engineering in France. So please feel free to contact me on this email or on LinkedIn. I'll be really very pleased to get in touch with you and to answer if you have like some questions. So the topic of today's presentation is about the brain-computer interface for industrial applications. So for that, we will give a brief introduction about the topic. We will talk about our research goals, our methodology and results, and then finally the conclusion and future direction. As an introduction, we'll talk about the brain-computer interface technology. So this technology allows the user to use his brain signals to interact with his environment, so external environment. So the idea is how to collect the brain activity, to record it using some measurements, for example, the electroencephalogram, and then how to extract some feature of interest, some characteristics of the brain signals that we call in neuroscience biomarkers. Then those biomarkers will be classified using machine learning, deep learning, or some signal decomposition methods to be then used to control some external devices or to give some commands to some machines. So we can use also those outputs as a neurofeedback to the user for some clinical applications, for example, for post-stroke rehabilitation. So this neurofeedback could be visual or auditory for the user. We can distinguish actually three main types of BCI. So the first one is an active BCI, reactive BCI, and passive BCI. So the first one, which means that the user should do like a mental task. For example, we can talk about the motor imagery, where the user should imagine that he is moving, for example, his arm, and we can create a virtual avatar or command a machine to do the action accordingly. And then we can actually rehabilitate the user from, for example, a post-stroke problem. The second one is the reactive BCI, which means we show to the user some external visual stimuli, so a visual or auditory stimuli, and we can talk about the SSVP, steady state visual evoked potential. So where we show to the user some external or icons that flicker on a specific frequency, where the user should gaze his attention on these icons to choose the action. Then when we analyze the signal, we can see this frequency, and we can know what was the choice of the user actually. The third one is passive BCI, which means we collect passively the brain signals using, for example, EEG, and then we try to analyze those the signals and those data to know if the user, if he is stressed, vigilant, or fatigued, etc. So now we will talk about how to use this technology and this process in industrial applications. But before that, we should talk a bit about how to rethink the fourth industrial revolution And we can't talk about the fourth industrial revolution without talking about other revolution of industry. So from mechanical, let's say, improvements of for the industry to the electrical and mechanical improvement, then how to automate the automation, let's say, of some industrial tasks in 69, and then until nowadays, the fourth revolution, industrial revolution, by using some smart technologies like applied AI, big data, internet of things, cloud computing. And then recent works are focused actually to how to use the next generation of fourth industrial revolution is about the brain computer interface, and how to use this technology to improve actually the industrial processes. So when we talk also about the industrial revolution, we talk about object control. And let me just introduce briefly the evolution of those technologies over time. So from the age of fixed point control, the operation of computer operating system, to the age of mobile touch and applications with the mobile operating system like Android, etc., iOS, and then the age of voice control, like how to recognize the speech and to the voice also, and to how to control some external objects by using only the voice. Then the image and visual image control with the image recognition and system. And we always like asking ourselves what will be the next actually in those technologies. And let me just say that the next revolution will be the age of brain control. So a lot of work and business report, let's say, talk about this evolution of technologies that could be found in on the net actually. So now we will talk about the research goals and methodology. So the main aim of this work is how to actually to explore what are the relevant applications of BCI in the industry 4.0. And the main aim is not to replace the human within the industry, but to reintroduce him within this his industrial processes by facilitating the operator's work and limiting potential risk and the human errors. And we will discover later how could this be done. And also the goal was how to identify relevant applications and which BCI techniques are most relevant for those applications. So for that, we carried out a literature review of recent works on those databases with the following queries. Like BCI and Industry 4.0, EEG-based BCI, BCI applications, BCI challenges also, and assistive technology for the period for the following period, like the last 10 years. And here we can see like some results that we got from this study. So the first one is device control. So the first category of BCI applications will be device control, how to assist the operator to control some devices and machine in the industry by using or combining the brain-computer interface technology with some other technologies already present in the industry, like augmented reality or virtual reality, or even mixed reality. And the main benefit is to help him to control the machine without by replacing some buttons or joysticks, to gain on productivity, minimize errors, and to allow him to work with hands-free. The second application is about the safety and training, and the idea is how to adapt the training and for learning optimization and evaluation of industrial processes by using his brain signal. So how could we adapt the task that he is doing according to his vigilance, if he's stressed or not, etc. And uh, the benefit is effective training, and the second one is prevention from accidents, and we will talk in more in the third category, which is the monitoring. And the idea here is how to use his brain signals to prevent him from errors and risky situation. So imagine that we have a driver or train or bus or something or machine, industrial machine, and we are collecting his data, which could be integrated with his helmet, for example, and we know and we detect if the driver is there is a loss of vigilance or he is stressed, etc. So we can for that improve the person ability to focus and capture emotion and in an emergency for decision making. And the main benefit is is that we can like give real time alerts, prevent him from risky situations, stress management for sure, and decision making. So those are the main BCI applications that we found in from our study, and we can't talk about the application of these technologies in the industry without talking about the main challenges. And for that, we have listed here some main challenges. The first one is the user acceptability, actually how to introduce this technology in real time and real world, and how the user could accept this technology by respecting the ethics, the confidentiality of his data, and the RGPD processes. The second one is the ergonomic. Could we give or product a BCI solution which is portable, not really easy to use, which help the user to do other tasks, and easy really for training and calibration phase, so which is not time consuming, and which could help the operator in his work. And the third challenge is technical. So how could we have like some algorithm or models to classify those brain data, let's say, with high reliability, speed, and flexibility. And the fourth one is the tech transfer. And here the idea is, could we actually product or give some BCI solution with some good development cost, with good time to market, and there is also the risk of first mover risk. So before considering any applications for real use, those challenges should be really studied and studied and by the developers, actually. And as a conclusion, we can say that so the BCI has a growing interest in the application of BCI. There is an interest in the application of BCI to industry nowadays. The deployment of those PCI applications remains very interesting, particularly for monitoring the mental state of the operator, device control, and the training of operators. So before any deployment in real time, in real life, let's say, some ethical, societal, ergonomic, and technical challenges should be addressed. So, and as a future work, we will focus on the main BCI paradigms paradigms suitable for industry regarding the identified application. Sorry. So with a view, let's say, of a neuroscience, let's say, techniques. So thank you very much for your attention. I will be really happy to answer your questions on